flipping work, got him hit with the ruler. Chasing dough, trying to make a pizza pimp, Nas brains blow, tomato sauce on the deep dish. We invincible till we get made invisible. This here is not difficult.
Okay, so today we will be learning about the periodic table of elements. So obviously it's a group of elements. So you have all these groups 1 through 18. So and then so you have all these groups which are columns that go down. You have periods which go across like that. So here's the period numbers right here. So it goes 1 through 7 for period numbers. Here's so these tannish ones are the lanthanoids, and here's the actinoids, which are the purplish ones. And so this table gives information about chemical elements, and the elements are grouped into 8 classes according to their properties. So, and each class is shown in a different color, which is how they organize the elements. So here's a look at all that. And so hydrogen doesn't belong to any of these classes, that's why it's in white. So none of the other ones are in white. So there's a little key. But so the atomic number, so if you were to look at one of these little squares, let's say, we'll just look at hydrogen, I guess. So we look at hydrogen, and the atomic number is up here, which is 1. So that little 1. And then here's the chemical symbol, which is H. And here's the element name, so hydrogen. And then the atomic weight, which is the number below it. So, and here's the number of electrons in each shell. So it has one shell with 1 electron. Like for lithium, it'd be like 2 in 1. And it's different for all elements. So, valence electrons. Valence electrons are depending on your group. So the groups are going down this way again. So groups are up here, and depending on what group an element is in, that's what it would be. Like, that's the number of valence electrons it would be. So let's say we do boron or carbon. Boron, it would be 13, since it's in 13. Carbon would be 14, nitrogen 15, oxygen 16, and so on. So same for that. And so, and then it was, I believe it was it was element 113, 115, and 117. These elements are currently unknown. So, and so I'll get into like what each element is. So group 1 down here, group 1 is the alkali metals. Group 2, these are the alkaline earth metals. Group 3 through 12, so all of these are the transition elements, or the transition metals. So And all of these in that light bluish color, those are polar metals, and the green is other metals, and all of the metals on the right side are metalloids. All these are transition elements and alkaline metals and alkaline earth metals. And so group 18 down here, those are the noble gases. So and yeah, so those are the noble gases. All of these in green are all of these in green are non-metals. Two could be other metals, but they're mostly non-metals. And you could also call these transition elements the lanthanide series or lanthanoids. And so you could also call these, like what I said, it was the actinoids, but it could also be called the actinide series. And and then there's also so the subgroup numbers 1 through 18. Here's like a little fact. So 1 through 18, they were adopted in 1984 by the International Union of Pure and Applied Chemistry, or the IUPAC. They were recognized authority in the fields of chemistry. It credits the discovery of elements and assigns names to them. So that's like how the periodic table is made. So for elements with no stable isotopes, the mass number of the isotope with the longest half-life is in parentheses. So here's a look at, and then there's like solid, liquid, gas, and unknown. So like I was saying, that's unknown. I don't know why these weren't unknown, because I know they're unknown. Oh wait. Okay, yeah. So oh wait, yeah, they are unknown, because it's the color of the symbol, which is red right there. That'd be a gas. So hydrogen's a gas. All of the black symbols are solids, so most of these are solids. There's some gases. Blue is a liquid, so there's one of the few liquids right there, solids right there, and this bottom row right here, this bottom period, seems like it's unknown. So here's a look at the periodic table again, and here's a little key. So that, and there's a bottom. So that is the periodic table of elements. So
yeah. Hey, listen, real skinny, loud colored tinnies, body marked up like graffiti. I don't push a Maserati, Beamer, Benz, or Bentley.
Okay, so today we're gonna be learning also about the atom. So this is concept. It's not today's model. Here's today's model. So the nucleus, which is this. The red is protons, which have a positive charge, and the white ones are the neutrons, which have a neutral charge. And these are all particles. So that's what makes up the nucleus. It takes up most of an atom's space. So that's a nucleus. And here's the electrons, which are these blue particles. These all have negative charges, and as you can tell, they sort of go around the nucleus. They circle around the nucleus, and around the nucleus is like electron cloud. It's an electron cloud, but it doesn't have that in this model. But that's where you can mostly find an electron. So like that, electron circles around the nucleus. So see, proton positive charge, neutron 0, and electron is negative charge. So done with that, and so here I believe it's Bohr's model. So Bohr's model, there's like, so it's one of the most accurate ones. It's not really that accurate, but it's pretty accurate. So I don't know what this is an atom of, but each atom represents a small part of the element, so it represents that element. So here's a nucleus. He has that. I don't know where the protons and neutrons are, but usually he would have the protons and neutrons. It's just that this picture doesn't have that. But the first shell has 2 electrons, so here's the first shell. It's that little circle, and so 2 electrons, which are those. The electrons are gray in this picture. Second shell, 8 electrons, so 1, 2, 3, 4, 5, 6, 7, 8. And third shell, 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's Bohr's model. So let's look at it again. Nucleus, electrons, and shells. So done with Bohr's model. Here's Thomson's model. It's like one of the very first ones, but so it wasn't really that accurate at all compared to today's model. So you look at this, and you look at today's model again. So as you can tell, it's just a ball, really, with protons and electrons. There's no neutrons, just protons and electrons inside the atom, which is the ball. So here's the electrons, which are negative, protons are positive. Nothing really special about it. So here's Demetrius. So he was like one of the first. He just had a ball. That's pretty much it. So 400 BC, really long time ago. Atom. Look at that. Look at today's again. So that it's really inaccurate compared to today's. So one more look. That's pretty much it. That's all about the atom. So I don't really think there was any electron cloud in any of these models, but that's like there wasn't any electrons, and well, there was, but there wasn't electrons in all of them. I don't think they had electron clouds, but this is today's model. Like, it's the most accurate so far, I guess, but circles around, and electrons have negative, neutrons have neutral, protons have positive. So this makes up the nucleus, and electrons are just particles found in electron clouds. And an atom represents part of that element that it represents, so that's pretty much it.
Flipping work, got him hit with the ruler. Chasing dough, trying to make a pizza pimp, Nas brains.